Okay, we've got a few more graphs left to look at. Next we have the cotangent graph. Its domain is going to have a problem when on the unit circle it was the ratio of x divided by y. And so it's going to have a problem whenever y is 0, which is going to be at multiples of pi and 2 pi. So anytime I'm at 0 or pi or 2 pi, we have a problem. So any multiple of pi, actually. So the domain is going to be x not equal to k pi. 0 counts as k pi because if k is 0, k is an integer, by the way. If I didn't define that last time, k is just any integer. So it's definitely not a fraction. It has to be a whole number, but positive or negative. So k is integer, so it can be 0, 1, 2, 3, 4. Any multiple of pi is going to make the cotangent graph undefined. All right. Its range, similar to tangent, is going to be all real numbers, so negative infinity to infinity. And its period is also pi. You can see on this one more clearly we have that 0 to pi as one period, then we repeat the same shape again. So its period is also pi. Okay, there are only two graphs left for us to look at. We've got the cosecant and the secant graphs. Remember, the secant graph is the reciprocal of the sine graph. So if I draw the sine graph lightly in here, its reciprocal would be the cosecant graph. That means that anywhere that the sine graph is 0, I would have 1 over 0 for the cosecant graph. So I have asymptotes at all of those places. Anywhere that I was at 1, I'm still at 1 for the height, because 1 divided by 1 is still 1. And anywhere I'm less than 1, you know, if you divide by a fraction, you get large, we're going to be very large. Okay, so a period of the cosecant graph is going to include 1 up and 1 down section, so it's going to be 2 pi long, and we'll get to that in a second here. So first of all, its domain, it's going to exclude all multiples of pi. We can't have 0, we can't have pi, we can't have 2 pi. So the domain is going to exclude k pi, all multiples of pi, because those are places where the sine graph is equal to 0. The range is going to be, it has to be either bigger than 1 or less than -1. So we're going to write this two ways, once in set notation, once in interval notation. In interval notation, it would be from negative infinity up to -1, bracket, union, bracket, 1 to infinity. I think I like interval notation here, but if I wanted to write it in set notation, it would be the set of all y such that y is less than or equal to -1, or y is greater or equal to 1. So you have to have both inequalities right there. One inequality satisfies each of the interval conditions. So less than or equal to -1, greater or equal to +1. So again, you can write it in either set notation or interval notation. If you pay attention to what my math asks you for in one of these, let me know, please. And the period, which we already discussed, pi only gets you 1/2 of the loop. These are not the same because one's positive, one's negative, so I need 2 pi to get the full period. And if I start going beyond that, I'll see another up, and so I'll have the same thing again. So I don't need any further than that. Okay. Last function, the secant function. We got the cosine lightly drawn in here so we can see its reciprocal function. This is the function we're trying to look at, the secant function. And any place, again, where the cosine function would have been 0, I have the 1 over 0, which is giving us that asymptote up there. And cosine would have been 0 at the multiples of pi halves, so that makes the domain of secant, x can't be those odd multiples of pi halves, so x is not equal to odd 2k plus 1 pi halves. Or, if you prefer to phrase it in the other fashion, x cannot equal pi halves plus k pi. Again, it's just the same exact thing. It's just written as one fraction or written as separate pieces. Same thing. Range, actually the same as we had for cosecant. We have that -1 and down, and we have that +1 and up. So the range is from -infinity to -1, union with 1 to infinity, or if I want to write it in set notation instead, set of all y such that y is less than or equal to -1, or y is greater or equal to 1. And the period of secant is, if I look at, we like to look at 0 to 2 pi, so if I go up, I go down, and I go back over, I can see that right between 0 and 2 pi, if I went any further up, I'd be repeating, because I have that part of it already drawn, so it's 0 to 2 pi again for its range. Or you can count from -pi halves to 3 pi halves, which is 4 pi halves, and therefore again 2 pi. So it is a 2 pi for its period.